Assalamu alaikum. This is GA RUBAYAT HYDER, matrix A17CS5335. I'm going to be explaining the Pearson R correlation to begin with, and I'm going to be doing so with this data set, which is tree height and trunk diameter. In order to do the Pearson R correlation, we could use a summation and drop this into a formula. However, Excel already does this for us, and there is already an existing data set in order to do this. In order to access this data set, all we need to do is go into File and go into Options. Inside Options, there's this menu called Add-ins. Press this and you have to install the Analysis toolpack. Press go. Okay, and it's already done, so we can use this to call in the Pearson R correlation. Now, it's important to remember that you need to keep both the columns next to each other. In this case, for example, we want to find the correlation between height and diameter. If I wanted to find the correlation between, let's say, a tree serial number and trunk diameter, I'd need to put them beside each other. So in this case, for example, we want to do the correlation between tree height and trunk diameter. What we do is simply we go to Data Analysis. Press that. As you can see, there are a lot of analysis tools already available. We can make a histogram, moving average, and whatnot. We could even do t-tests. Now, we're going to simply select correlation. This correlation, mind you, only mentions the Pearson R correlation. So, okay. Now, what we do is we need to select the input range. And in this case, you could simply do this by pressing on that and selecting these. Now that has been done, mind you, this dollar sign is to indicate that the blocks are not moving and this is a constant. And let's say I want to select an output range. So there you go. Let's say I select this, let's redo that. Right. So I select this output range, and given that we selected the labels in the beginning, we needed to tick this box, in which case this would omit the top label over here, tree height and trunk diameter. However, since we did not, therefore this is not selected. Simply press OK, and there you go, that's it. So column 1 is tree height and trunk diameter is column 2. Now the correlation between column 1 and column 1, which is tree height and tree height, is obviously 1, and column 2 and column 2 is 1. Now what we want to find is this answer, which is the correlation between tree height and trunk diameter, which gives us a value of 0.886231. This is a very high positive value, so we can say that there is a very high correlation between tree height and trunk diameter. This can be proved by this, and it is true in this case. Moving on, we're going to be doing the correlation with Spearman's RHO. Now, we have these two values, which is ranks of scores by judge A and ranks of scores by judge B. Now, the Spearman RHO or Spearman row correlation doesn't actually work with the sets itself, but rather once they're in ranks. So we need to find these ranks as it is. In order to do this, I'm going to use this other function, which is equal to rank, R-A-N-K, dot AVG. Now once we start, it's going to ask us for the number to start with. So we do that, we select this, comma. Now the reference is this whole block, because that's how we want to rank them, comma. And finally the order, we want them in an ascending order, so I'm going to give 1 and close the box. And this value in particular has a rank of 7. Now what I'm going to do is I'm going to add a dollar sign before the B of every one of these, and the 2's, and the numbers. My bad. this way, this value is the only thing that doesn't change, and it's easier to copy because I do not want to keep repeating this over and over again. Value remains the same, and there you go. Now notice how there are these decimal figures. This is because some values are the same. This value, for example, is 2.5 because this 2.5 and this 2.5, there's two values of 2.5 existing. Therefore, it ranks them as an average. I do the same thing here. And the number is this, comma, reference, comma, ascending. .5. As you can see, there are there are two values of 5.5. Therefore, the order made an average of these. Now, I'll do the same thing here. Shift 4. There you go. Having done this, I could now copy this simply throughout, and I have the rank. After the data has been ranked, we need to find the difference between these two datas and find the squared value of this data in order to find the Spearman row correlation. In addition to that, after we have done all of this and found the summation of the difference squared, we need to put this in a formula, which, as we know, is 1 minus 6 summation of the difference squared divided by n into n square minus 1. N being the total number of data points that are being used. So let's say we call this place difference. So let's say I short this for d, and in this case this would be d squared. There you go. So in order to do this, we simply use another function, which is we call in and equal to, call in rank 1 minus rank 2. Press enter, and that's the difference between 7 and 5.5. Now we repeat this for all of these values, right? So we simply copy this down, and there it is. Now all of these values, once squared, will be a positive number. Hence we have d squared, which is simply equal to this value, which is f2 squared. Press enter, and that's the value for d squared. We repeat this for all of these available values, for all the values in the data set, and find the summation. In order to find summation, we use another function that we already know of, which is sum, sum. Open the bracket and drag these numbers, close the bracket, enter. So the summation is 146.5. Now, in order to find the correlation, we need to ensure that we apply the right formula. The formula, as I have already said, 1 minus 6 summation of d squared, which is this value right here, divided by n into n square minus 1, n being the total number of data points. So we write that down, equal to 1 minus, bracket open, 6 times summation divided by n. In this case, n is 10, so I could simply use this 10. Ten square minus 1, and close the whole thing together. Enter. Oh, there was a typo it seems, but yeah, the typo has been fixed, and this is the value. Correlation according to Spearman-Rove is 0.112, 121212. So this value, as we see, is a positive correlation, however, albeit a very small one, but it is a positive correlation as compared to the other correlation that we had in Pearson R, which used a different data set altogether. The correlation was 0.886231, which was a much larger correlation as compared to 0.112 that we found between the ranks of scores by Judge A and Judge B. Alright, so there's the correlations do differ according to the formula and is a bit different. However, these are still positive correlations, and these are as per the examples that were given to us in the slides. Thank you.